Hi, everybody. Welcome back to For the Girls. We're also doing a segment in case you are wondering what on earth a power unit is. The term gets thrown around all the time. They explode, they cause grid penalties, they're unreliable, and especially if you are a Ferrari or a Red Bull powertrain, they are fast. So stick around for that. And with that, I'm Tiggy.
I'm Sarah.
And I'm Chessa. Okay, so now into our fun section, we're going to get a little crazy with you and talk about what in the world is a power unit. So like Tiggy said, the term gets thrown around a lot. We've talked a lot about it with both Ferrari drivers getting new power units and taking grid penalties. So let's talk about what it actually is. We'll try to demystify it for you. And although it's infamously complicated and notoriously hard for even these teams to master, we've clearly seen a lot of issues that they've had with reliability. We're going to try to break it down for you and make it easier to understand. So basically in Formula One, there are 4 power unit manufacturers. There's Mercedes, Ferrari, Renault or Alpine, and the Red Bull powertrains. These are referred to as the works team since they build their own engines and the rest of the teams are customer teams. So Mercedes supplies McLaren, Aston Martin, and Williams. Red Bull supplies AlphaTauri. Ferrari supplies Alfa Romeo and Haas. And Alpine supplies its Renault to itself, but Williams is potentially switching to Renault yet next year. So it sounds weird that so many teams have the same power unit manufacturers, but the differences in performance really emphasize how much more goes into it than just the engine, right? There's aerodynamics and everything else. Red Bull's arguably the fastest car on the grid right now, yet AlphaTauri has the same engine as them, and they're not having a great season. Same with Williams being at the back for years with a Mercedes engine. So there's so much more to the car than just the power unit.
We'll start with a little technical talk, but also go into some of the more practical implications of all this. So rules, regulations, why it's impossible to restart a race once your engine shuts off, etc. Since 2014, what used to just be called an engine is now a power unit due to them being hybrid. So a power unit consists of a petrol internal combustion engine or an ICE, which is what you can think of as the more traditional gas-powered engine. It's a 6-cylinder turbo V6 with 1.6 liter displacement, and it runs on pretty standard fuel, but 10% of that fuel mix has to be sustainable ethanol, and that's something F1 is trying to increase moving forwards. And the turbocharger is a component of this that affects how the engine consumes air from the exhaust and pressurizes that air to help power the engine as well. Then we have the hybrid part, which we're going to get more into, but is overall called the Energy Recovery System, or the ERS. And the total package altogether is about 1,000 horsepower. And one of our favorite fun facts is when the hybrid engines were first introduced, people complained about their lack of noise compared to the previous V8 engines and the V10 engines before that, which is funny because the old V8s definitely sound different, but the new engines are still so loud.
Yeah, like unbelievably loud.
So loud. But I guess we don't technically need earplugs, whereas you probably definitely needed them beforehand if you were there in person. So let's talk more about the hybrid components, the ERS, which are so cool. So this system recovers energy from the exhaust and from braking, and it converts it into electricity to either power the electric motors directly or be stored in a battery for later use as an extra power boost. The battery is called the Energy Store, or ES, and there is also the control electronics, the CE, which is basically the brains of the car and lets the driver control the functions of the power unit. So 2 crucial parts of the system are the MGU-K and the MGU-H. Both motor generator units convert their respective energy sources into electrical energy, which can then be used to propel the car. So an MGU-K, which stands for Motor Generator Unit Kinetic, is an electric motor that changes its function based on mode. So in regenerative mode, it works as a generator that slows the car through engine braking, which produces electricity to charge the battery through the braking process. And then in drive mode, it becomes a motor using that electricity to accelerate the car. But this can only be used about 30 seconds per lap. So there are limits to how often you can do that.
It's so cool. Like the braking itself can charge the battery. It's
wild.
Awesome.
It's so cool. So the second unit that Tiggy talked about, the MGU-H, that stands for Motor Generator Unit Heat. This is a little bit more complicated, and it's used in combination with the turbocharger that we mentioned earlier. But basically, this unit can also work as a generator. it creates resistance that slows down the spin of the turbocharger that we mentioned, and it turns this energy into electricity that then gets stored in the battery. And when it's used as a motor, it can keep the turbocharger spinning even when the driver is not on the throttle, which reduces in turbo lag and is more efficient than the fuel-powered alternative. So the electricity generated by the heat motor generator unit can also power the kinetic motor generator unit. And what's really interesting is we talked about all of these different parts. All of this together has to weigh at least 150 kilograms, just over 300 pounds. Obviously, right, because weight slows the car down and the cars would be incentivized to all just drop a ton of weight, but there's kind of like a minimum that they all have to keep.
And so these motors generate an incredible amount of power, but teams have different ways of delivering this power, and drivers and teams can choose from different modes and let the car do the rest. So we have different power unit modes. So for example, depending on race conditions, the power unit can be in more like a full send mode when you're pushing in quali, or it can be in a lower performance mode in different conditions. So for example, the cars would be put in probably a lower performance mode if a driver is stuck in midfield traffic and is concerned about overheating the engine because of bad airflow. So this leads us to the battery. As we're talking about the MGU-H and the MGU-K, the hybrid components overall generate electricity that powers the battery. And then this extra energy can be strategically deployed during a race for basically an extra boost. But while the battery is charging up and in an energy collection mode, that causes that red light to flash on the back of the car. And then this light also flashes more fully during wet conditions for safety. But during normal dry conditions, when you see that red light flashing, it means that the battery is charging up in that car.
Wow, that's so cool. Just a quick note on engine cooling. So we don't have a ton of time to get into this in too much detail, but as you can imagine, this whole setup generates a huge amount of heat. And the body of the car is designed to create airflow that cools the engine. And inside the car, there are more complicated air/water coolers as well. All very interesting, which brings us to the power unit regulations. What's funny is there used to be no limits to engine use. So teams would develop these crazy tuned up engines that would really only last several quali laps. But
and sometimes
now,
they're referred to as party mode. So they could go into these insane modes and almost like blow up the engine. And now that's not allowed anymore.
I love that. Yeah. So because of that, now per season, each driver is allowed 3 engines, turbochargers, MGU-H and Ks, 2 energy stores and control electronics, 8 sets of engine exhaust systems, and anything beyond this causes drivers to take grid penalties and start at the back of the grid. This is what has been a hot topic recently because if these components are failing or blowing up and the team needs to use more, it can really hurt the driver over the course of the season. So it's a very fine balance of how tuned up can we go without all of these reliability issues. How does the FIA regulate these and make sure everyone is following the rules? Electrical sensors from the FIA's designated suppliers are attached to different parts of the ERS for monitoring. There's also a torque sensor fitted to the MGU-K, and all cars run the same high-pressure fuel pump manufactured by the FIA World Motorsport Council. And for the petrol engine, the power output shaft and drive shafts are fitted with a torque measurement system, and there are pressure and temperature sensors as well. So the FIA is constantly looking at all of these to regulate them and make sure everybody is in compliance.
That's so much data generated from each car. That would be a really cool job to try to look through all of it and make sure everyone's following the rules. Last thing about power units here. How do you start an F1 engine? Most cars, like the ones that we drive every day, have these like electric starter motors that just allow us to turn a key or press a button and start the engine. F1 cars don't have these on board just because they'd be too heavy. So instead, there's a bunch of steps that the entire team has to do to get the engine running. High level, the team uses computers and they plug them into the car to first check that every engine or every part of the power unit is working. And then the engine is heated by circulating hot coolant throughout the engine and the radiators. Compressed air is also added, and then the petrol engine is cranked using an external start motor that they kind of like plug it into the back of the car. So everyone is monitoring everything that's going on, and then once the right temperature and oil pressure is reached, a mechanic sits in the cockpit, so where the driver would usually sit, and they use buttons on the steering wheel to turn on the fuel systems and ignition. The ignition is kind of like what makes it all start firing once everything is good to go. And then the starter motor will continue to crank the engine a little bit on its own until it fires up and is fully ready to go on its own. So because of all of the work that it takes to start the engine and all of the data involved and all of the people involved, the engines have these anti-stall systems that help the engine from cutting out during the drive. So for whatever reason, like a driver loses control for a little bit, the engine won't just stall and turn off. It'll try to keep itself going because, as we've said, once you're out there on the circuit and your car stops, if you have to go back to the pits to get it started again, you cannot restart the race.
In terms of where we're going with this, as we've mentioned before, there's currently a freeze on these designs. So this means that teams can't continue to develop these engines. And the idea is that that will make way for the new hybrid engine era focused on higher levels of sustainability that are being introduced in 2026. So right now, teams can still work on a few power unit components like the battery and the MGU-K, but that all gets frozen on September 1st. So basically, the power units for this season will be the same for the next 4 years until the 2026 regulations come into effect. But there is a really big but here. The regulations provide that manufacturers can apply to the FIA to make changes, quote, for the sole purposes of reliability, safety, cost saving, or minimal incidental changes. So the key word here is reliability. So there's a big cost benefit analysis here because it incentivized teams for this year to really prioritize engine power and performance way more than reliability, because this freeze is going to go into effect and they'll be allowed to make reliability changes going forwards, but they won't be able to make fundamental changes to make the engine more powerful. So a lot of commentators think that's kind of why we have all these reliability problems and Ferrari engines literally blowing up, because they wanted to just do everything they could to make it as powerful an engine as possible and kind of deal with reliability later after the freeze goes into effect. So definitely stay tuned for how that shakes out the rest of the season.
Yeah, maybe Ferrari's playing all of us. They really just know what they're doing. Let's hope.